So now that we know how to calculate z-scores and we know how they relate to the normal distribution, let's take it one step further and talk about what it means in terms of the population. Alright, and so let's add some percents. So how does the z-score relate to percents? Well, the normal distribution represents the entire population. And so when we say represents the entire population, we say that it represents 100% of whatever population that the researcher is interested in studying. So 100%. And so we can now divide that 100% into regions of our normal distribution. And so depending on the z-scores and how they deviate from 0z, or from the mean, from the center of the distribution, we can determine what percent of the population falls within each of those regions. So if we look at our normal distribution, and if we subtract 1z from the middle of our distribution, from the mean, and we add 1z from the middle of the distribution or from the mean, then we create a region that is called average. And in the average, so in other words from negative 1z to 1z, we would expect to find 68% of the population. So from 0 to negative 1z is 34% of the population. From 0 to 1z is also 34% of the population. And that's because the distribution is symmetrical. It's symmetrical about the mean, or the middle of the distribution. And so what occurs on the left side of the distribution also occurs on the right side of the distribution. So when we go from 0z to negative 1z, that region consists of 34% of the population. If we add it to the percent of the population from 0 to 1z, we end up with 68% of the population will fall between a negative 1z score and a 1z score. And so z-score negative 1 to z-score of 1. And we call this region average or normal. The next regions that we'll talk about under the normal distribution are the regions that extend from negative 1z to negative 2z and from 1z to 2z. So note again that the distribution is symmetrical, and so the percents of the populations that fall within each of these regions is the same. So 14% falls between a z-score negative 1z and negative 2z, and 14% of the population falls between z-scores of 1 and 2. So how we talk about or categorize these two regions is a little bit different. So we'll start in the negative direction, where we have a region between negative 1 and negative 2z. Here is 14% of the population, and we would classify people with scores within this region as below average. Now if we go in the positive direction, so scores between 1z and 2z, again 14% of the population, we would classify people that fall within this range, 1z to 2z, as being above average. And so as you can see from our distribution, that we have the center from negative 1 to 1z, which we call average, and then that extends to below average to above average. The last region of the distribution that we'll talk about is the extremes, or what we call in the tails of the distribution. So here it's a normal distribution, so it's symmetrical. We have two tails, one in the negative direction, one in the positive direction, and these tails extend from negative 2z to negative infinity, and from positive 2z to positive infinity. And so if we look at the negative side of the distribution, to the left of our distribution, from negative 2z to infinity, we would say that would account for 2% of the population, and we would label that percent of the population as extremely below average, or what we call extreme scores. Now in the positive direction, so if we go from the center of our distribution and go in the positive direction, for those values that are above 2z to infinity, we would say that is extremely above average. So that again encompasses about 2% of the population. So if we have someone who has a z-score of, let's say, negative 4.13, we would say that that person is extremely below average, or what we call an extreme score. If we had someone who had a z-score of 2.57, well, that would be above a z-score of 2, falling within that 2% of the population. We would say that that person is extremely above average. Let's go ahead and put all of our regions in percents on our distribution graph here, so we can see them all at one time. And you'll see if you add up all these regions, 2% plus 14% plus 34% plus 34% plus 14% plus 2%, would give us a total of 100%. In other words, the entire population. So we can divide up our normal distribution in these regions, and each region corresponds to a particular percent. Now you should have these percents memorized, so you should be able to know, if you're asked what is the percent of the population that falls between a z-score of -1 and -2, you should be able to respond with 14%. Also be able to add and subtract these regions as well. So if you're asked to say what percentage of the population falls between a z-score of -1z and 2z, then you should be able to say 82% of the population. We would add 34% plus 34% plus 14%, and we would get 82%. So have these committed to memory so that you'll be able to know what percentage of the population fall within each section of the normal distribution. You should also know that z-scores between -1 and 1 we would say are average or normal. Z-scores between -1 and -2 we'll say is below average. Z-scores greater or less than -2 we would say is extremely below average. Z-scores between 1 and 2z we would say is above average. And z-scores greater than 2z we would say is extremely above average, another extreme score. What's nice about the normal distribution is once we divide it into percents, then we can use it as a probability distribution. What I mean by that is that we can treat it like it's a pair of dice or flipping a coin where there's a certain probability associated with it. And so without knowing anything about a particular person, so for example, let's say someone's IQ, I can assume that the chances are that person will fall within the normal range. And I can make that assumption because the majority of people would fall between a z-score of -1 and 1z. In particular, I could say that there is a 68% chance that any one person will fall within that average or normal range. And again, I get that by adding the percents from -1z to 1z in that region we determine as normal or average. So 34% plus 34% tells me that any one person has a 68% chance of falling within that average range. I can also look at it and say that that any one person only has a 2% chance of falling within the extremely below average range, because that's where 2% of the population falls. And so once I have my population distribution segmented out in terms of percentages, then I can start making estimates or probability guesses based on that information.